Hey guys, Mr. T in your next video. This is on annualizing an interest rate, which is exercise 3C.5. It's another one involving using your calculator. So you're going to be asked a few questions, and maybe later on in life you might be comparing interest rates on an investment between two different banks or more than two. And it's easy if they have the same compounding periods, so say compounding every year, compounding monthly, then you can easily compare them because the higher rate's going to be better. They're compounding the same as just as often as each other, so you're just looking for a higher interest rate percentage. Also, if they have the same interest rate, then it's easy to compare because the more often they compound, the higher your investment is going to be. So it's easy if one of these elements is the same, if the compounding period is the same or the interest rate is the same. But what if the two things that you're comparing, or the things that you're comparing, have both different rates and compounding periods? You have to have a way of comparing the investments fairly, so comparing apples to apples or oranges to oranges. So the way you do this is to annualize the interest rates of those investments. So that means you are basically, like, the best definition of it is you're converting the interest rate of that compounding investment, whatever the compounding period is, to the equal rate if it was yearly. So you're just changing it to be, what would the interest rate be if it was compounding yearly instead of whatever the compounding period was for the rate that they're saying. Now thankfully your calculator can do this with the EFF function that's on your graphics calculator. So how do you access that? I'm going to show you how you do that on the TR-83. So turn your calculator on. You need to make sure you're on the standard calculator screen. So when you turn it on, you've got the little cursor flashing up, ready to accept numbers, like as if you were just calculating a normal function. You have to do it from there. So then you press Apps. The little menu comes up, select one finance and press enter, and now you have to scroll down quite a way, down to where the numbers actually become letters, down to C, and the little triangle and EFF, and press enter. So that actually pops up on your screen. You're going to see on your screen EFF and then the start of a bracket pop up, and then the cursor is flashing and you need to input stuff. And what you input next has to be the interest rate that you're trying to convert to yearly, and then separate that with a comma using the comma button, which is in the just above the numbers on your calculator, just above the 7 it should be. And then after the comma, you immediately put the number of compounding periods per year for that particular rate that you're converting, and you press enter. So for example, EFF bracket and then 4.89 comma 12. So I'm going to put that in 4.89 comma 12. You can end the bracket if you want, or you can just press enter. So what that is telling you, that input that you're doing is converting a 4.89% per annum interest rate, which is compounding monthly, because this is the interest rate that you put in, and then a comma, and this is how often it's compounding. And what it's going to spit out when you press enter is the annualized interest rate. So what the interest rate would be if it was compounding per year instead. So when I press enter, after I put this 4.89 comma 12 into EFF, it comes to 5.001099. So just pretty much 5.00 to 2 decimal places. Obviously it's not exactly 5, but with rounding, we're basically saying that that 4.89% interest rate compounding monthly is essentially the same as 5% per annum compounding every year. So we converted that 4.89% per annum compounding 12 times a year to what it would be per year, which is actually 5% per annum. So just remember, just for your knowledge, that the answer that you're finding there is called the annualized interest rate, which I've said before, or sometimes it's called the effective interest rate. And this is pretty much what they call it on the bank websites, the effective interest rate. Some loud birds outside. Alright, so I'm going to run an example here. If you're given a question like this, we're trying to compare two investment options. Maybe these are two banks. One is 8.5% per annum compounding quarterly. One is 8.4% per annum compounding monthly. Well, on initial look, you might say, 8.5% per annum is going to be better because it's a higher rate, but it's only compounding 4 times a year. Whereas this one is only 0.1% lower and is compounding monthly. So how do you know? How can you be sure? So that's what EFF is useful for. I want to get an effective interest rate on 1, so I'm going to go EFF, and this is how you would show you're working out. You have to show what you're putting into EFF. So go to Apps, Finance, scroll down to C, EFF, and so my current, this is actually called the nominal interest rate here, what it says it is. My nominal interest rate is 8.5%, and then comma, and if it's compounding quarterly, how many times is that per year? Well, it's going to be 4. So 8.5 comma 4, end the bracket, press enter. So that comes to 8.77% to DP, and that's per annum. So that's what the interest rate of 8.5% per annum compounding quarterly, that's what the interest rate of it would be if it was compounding per year. So we have, let's say this is our apple, and we want to compare it to another apple by doing EFF again, but on the next one. So the nominal interest rate, I should use that as a, I should actually note that, what that is. Nominal interest rate is the named interest rate. What it says it is in the question. Alright, so that's the nominal. So the nominal for number 2 is 8.4, comma, and if it's compounding monthly, it's going to be 12. So open up EFF again, put in 8.4, and then put a comma, and then put 12. That comes to 8.73% per annum to 2 decimal places. So what we can see here, therefore, 1 is the better option because the effective, or what we've said is also called annualized rate, is higher at 8.77% versus the 8.73%. Alright, so that's a basic comparison there using EFF, nice and quick. You don't need to do any hard calculations there, and that'll cover you for exercise 3C.5. So hopefully that helps you out, and I will see you on the next video.